Hi and welcome to my channel, JaberTime. Today I'm going to go over functions, domain, and range. A function is a relation in which each possible input value leads to exactly one output value. That's two conditions. Each is one condition and exactly one is the second condition. The input values make up the domain and the output values make up the range. Let's take a look at some graphs, some examples, and clear things up. In this graph, I have a mapping between 3 letters and 2 letters right here. These are called the inputs. These are called the outputs. The domain will be P, Q, and R. The range will be M and N. Is this a function? Well, if it's a function, each input has to have exactly one output. P has only one output. Q has only one output. R has only one output. I know they share the output, but that's not part of the definition of the function. It has one arrow going out of it, which is a function. So this relation is a function. Here's another example. This is straightforward. I could see that every input has exactly one output. So yes, it's a function. Here's another example. In this case, Q has 2 outputs, and that's not agreeing with the word exactly one output, so it's not a function. Here's a graph of a second degree equation, a parabola. Here they want you to find f of 2, and they want you to solve for f of x equals 4. In other words, giving the input 2, what's the output? Here, they gave you the output for what's x, what's the input. Let's move it to the left so I could put some work right here. Looking at the graph, f of 2 is going up to 1. F of 2 is 1. And this coordinate is 2, 1. So f of 2 is 1. Now let's look at the second part, which is, the output, which is 4, the y value, leveled at 4, what x values produces y equals 4. Here's a graph. Making a horizontal line at y equals 4, I could see that when y equals 4, I have 2 values. When x equals 3, I have y equals 4. When x equals -1, I have y equals 4. So this has 2 answers. F of x equals 4 implies that x equals -1 and x equals 3. Let's talk about the vertical line test since we have graphs. The vertical line test can be used to determine whether a graph represents a function. If we can draw any vertical line that intersects a graph more than once, then the graph does not define a function, because a function has only one output value for each input value. Here's a graph. Using the vertical line test, if this vertical line, I could graph it anywhere I want. Every time I graph it in any different place, it's going to cross the graph only once. So that's a function. Let's go back to the definition to support. A vertical line test can be used to determine whether the graph represents a function. If we can draw any vertical line that intersects the graph more than once, then it's not a function. It's not. In this case, only once, so it's a function. This vertical line at this location, for example, crosses the graph more than once, so it's not a function. This graph, using the vertical line test, is not a function. This graph, using the vertical line test, is not going to cross it more than once anytime you graph it, so it's a function. This graph is a function. this graph is not a function. You could graph it here, you could graph it anywhere. It's going to cross it twice. For example, if you graph it on the y-axis, it's going to cross here and it's going to cross here, which is at 0, 3 and at 0, -3. So in other words, 0 has two outputs, 3 and -3. That's not a function. Here's another graph. You could graph it here instead of here. It's at 2, you have like 2 point something and -2 point that exact amount. It's not a function. That shows that you have 2 points for the same input. The input 2 has two outputs just to support, and it's not a function. Absolute value functions using vertical line, it's a function. Using the horizontal line test. The horizontal line test is not the vertical line test. We use a vertical line test to determine a function, a relation, if it's a function or not. Vertical line test is to determine if the relation is a function or not. We use the horizontal line test to see if we can inverse or invert the function. So the functions that are onto and one-to-one, let's just focus in this video about one-to-one. If it's not one-to-one, it's not invertible. All right. There is more videos for that, advanced, but at this time we'll just keep it simple to know what's one-to-one and what's a horizontal line test. One-to-one function. A one-to-one function is a function in which each output, see that it's the other way around, each output value corresponds to exactly one input value. There are no repeated x or y values. Well, no repeated x because it's called a function. Now we're questioning if this function is one-to-one. So on top of that, we are seeing if the y values repeats. Once we have determined that a graph defines a function, as I said, we just go further and to determine if it's one-to-one. An easy way to determine if it's one-to-one is to use the horizontal line test. You draw a horizontal lines through the graph. If any horizontal line intersects the graph more than once, then the graph does not represent a one-to-one function. Here's an example. This right here is not a one-to-one function because this horizontal line crosses the graph more than once. Of course, there's more than one horizontal line that does that, but as an example, it's not a function. And we can't find the inverse for it. The inverse would be like switching x and y. That's going to be a different video talking about the inverse and how do you find the inverse, how do you reflect and graphically, and how do you do it algebraically. Now, families of functions. It's good to know like types of functions because functions are not just like slope, y-intercept, like 5x plus 2 and so on. A lot of things in life, they behave in certain way and we describe them with math functions. So here's a function. It's called f of x equals c, where c is a constant. Here's the graph. It's always constant. -2 will take you up to 2. 0 will take you up to 2. 2 will take you up to 2. So we call it a constant function. This function is y equals x, a 45-degree graph from the positive x-axis. You go up to 2. You go 0, stay 0. -2 will take you down to -2, as you could see. We call it identity function. So whatever you input, you get exactly the same output. It doesn't change it. That's called identity function. This with vertical lines to the right and left of x, we call it absolute value function. And the absolute value says if you have a negative, you change it to positive. Sometimes we define it as distance away from 0. To support that distance is positive, is never negative. So the outputs for this function are always non-negative. If you put 0, you get 0. If you put 2, of course it's 2. But if the input is -2 right here, the output won't be down here, will flip, will change back to +2. and this is called absolute value function. Y equals x to the second is a second degree. It's a simple second degree function. We call it in higher math the parent function. This is how we graph it. You plug in 0, you get 0. You plug in 1, you get 1. But when you plug in 2, you go all the way up to 4. If you plug in negative 2, negative 2 squared is positive 4, as you could see. And this is called quadratic function. X to the third is called a cubic function. When you plug in 1, you get 1. When you plug in 2, you get 8. 2 times 2 times 2. That's why it goes all the way up, faster than x to the second. But when you plug in negatives, in this case, you still have negatives, because negative number like negative 1 times itself 3 times, an odd number of times, will stay negative. 1 over x. This is how it looks like. Once you plug in very small numbers like 1 over 0.01, that's like 1 over 100ths, it's gonna flip it and it's gonna give you 100. That's why as you approach x, as x approaches 0 from the right, you're gonna go all the way up, and same pattern, but negative will stay negative as you approach 0 from the left. You can't plug in 0, that's why we are not touching the y-axis. This is called the reciprocal function. In case if you square the x to the second, you're not going to get negatives, just like this guy. When you put negative 2 down here, that's going to be negative 2 squared, which is 4. 1/4 is right here. So 2 will take you to 1/4. When you plug in negative 2 squared is still 4. So the output is still 1/4 also. So instead of going down, you're going to be reflected above or about the x-axis to the top. And this is called the reciprocal squared. Y equals square root of x. You plug in 0, you get 0. Square root of 4 is 2. Square root of 1 is 1. And it's kind of like a curve that slows you down as you go farther to the right. So if you go all the way to the 100, square root of 100 is 10. You just go up 10 units. There is nothing on the left because you can't plug in negatives inside the square root. Square root of negative 25 is not 5, and it's not negative 5. In higher math, we call it imaginary number, which is 5i, I for square root of negative 1. Excuse me. Now, so this one is called square root. This one is going to be called cubic root. Negatives will stay negative, positive will stay positive, and we could plug in negatives in this case. But, you know, like plug in negative 1, you get negative 1. Plug in 1, you get 1. But if you plug in, let's say, 8, you're going to get 2. Cubic root of 8 is 2, because 2 times 2 times 2 is 8. If you plug in negative 8, you get negative 2. Because negative 2 times negative 2 times negative 2 is negative 8. So yes, you could plug in negative numbers, and that's why it continues down here. You go all the way to negative 8, you just output going down to negative 2. And that's called cubic root. Determine if the relation is a function. Well, looking at the inputs and outputs, I have negative 1 is taking me to negative 1. I have negative 2 is taking me to negative 2, and negative 3 is taking me to negative 3. If I look at it from a different point of view as a mapping, every input has exactly one output, so that's a function. 3 is going to 4, 4 is going to 5, 5 is going to 6. Every input has exactly one output, so it's a function. Another example. Let's look at it as a mapping concept. 2 is going to 7, 7 is going to 11, to 5, 7 is going to 11, 15 is going to 8, 7 is going to 9. Maybe it's not fully clear, but let me highlight things for you. Notice that 7 here and 7 here, so x repeats, In other words, 7 is going to 11 and 7 is going to 9. Differently, I'm saying that 7 has 2 outputs, so it's not a function. So x cannot repeat to call it a function, all right? How about this one? Here's the inputs 5, 10, 15. Well, it's not repeating. I know they share here 8, but that's no problem. 5 has only one output. 10 has only one output, which is 8. 15 has only one output, which is happen to be the same number 8. But every input has exactly one output, so it's a function. Here's another example. Notice that 10 is going to 8 and 10 is going to 14. That means 10 has 2 outputs, which contradicts the condition that says exactly one output, so it's not a function. Another example, maybe that should do it for this video. If you have a table and they want you to find f of 3, well, I need to locate 3 as an input. I see it right here, and it's not repeating, and they call it a function, so it's fine. So we need to focus right here. And they want me to find the input that gave me an output of 1. So down here, those are the outputs. I see the output 1, so here we go. For f of 3, it's taking me to the output 53, so the answer for the first part is 53. And if the output is 1, the input is 2. That means x equals 2, and that should do it. I think that's good enough for this video, and I'll see you in the next one. Thank you. Thank you for watching. Don't forget to hit the like button, subscribe to see some more, and I'll see you in the next one.